The complement of an event. The complement A prime of event A is made up of all members of the experiment's sample space which are not contained in event A. For example, consider the experiment of throwing one die. The sample space of a fair die is S, equal to 1, 2, 3, 4, 5, and 6. Let's define an event A as observing an even number so that A equals 2, 4, and 6. The complement of A will be all of the elements of the sample space which are not in A. Hence, A prime is equal to 1, 3, and 5. We can use a Venn diagram to illustrate the relationship between A and A prime. We can see from this diagram that the sum of the possible outcomes for event A and the possible outcomes for its complement A prime is all of the possible outcomes in the experiment's sample space. According to the complement rule, the sum of the probabilities of an event and its complement must be equal to 1. Symbolically, P of A plus P of A prime is equal to 1. It is sometimes easier to calculate the probability of the complement of an event than it is to calculate the probability of the event itself. In this situation, the probability of the event, P of A, is calculated by using the relationship P of A is equal to 1 minus P of A prime. For example, suppose you know that the probability of catching a cold this winter is 61 hundredths. What is the probability that you will not catch a cold? Let the event A be catching a cold this winter. The event of not catching a cold is A prime. Therefore, P of A prime is equal to 1 minus P of A, which is equal to 1 minus 61 hundredths, which is equal to 39 hundredths. In our next example, two coins are tossed simultaneously. Let the event A be observing at least one tail. What is the complement of A, and how would you calculate the probability of A by using the complement rule? Because the sample space of event A is equal to heads tails, tails heads, and tails tails, the complement of A will be all events in the sample space which are not in A. The complement, therefore, will be all of the events in the sample space which do not include tails. A prime is equal to heads heads. Again, we can use a Venn diagram to represent A and A prime when tossing two coins. To calculate the probability of A using the complement rule, recall that P of A is equal to 1 minus P of A prime. P of A prime is equal to P of heads heads, which is equal to 1/4. P of A is equal to 1 minus P of A prime, which is equal to 1 minus 1/4, which is equal to 3/4. Of course, in this situation, we could easily have directly calculated the probability of the occurrence of event A. For our next example, consider the experiment of tossing a coin 12 times. What is the probability that we will observe at least one tail? It would take a very long time to list all of the simple events of this experiment. One would be heads tails, heads tails, heads heads, heads heads, tails tails, tails heads, and another tails heads, heads heads, tails tails, heads tails, tails tails, heads heads. There are actually 2 to the 12th power, which is equal to 4,096 ways to observe at least one tail in 12 tosses of a coin. Keep in mind that every time a coin is tossed, the chance is the same for heads as it is for tails. In other words, each simple event among 4,096 is equally likely to occur. Therefore, the probability of any one of these events is 1 over 4,096. Since tails will almost always occur at least once during 12 consecutive tosses, it would be quite time-consuming to directly calculate the probability that we will observe at least one tail. However, the complement of A prime, contains only one event: heads, 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 12 consecutive heads. Thus, P of A prime is equal to 1 over 4,096. Using the complement rule, P of A is equal to 1 minus P of A prime is equal to 1 minus 1 over 4,096, which is equal to 4,095 over 4,096, which is equal to 99,976 100,000ths. Therefore, there is a very high percentage chance of observing at least one tail in 12 tosses of a coin. The standard English definition of the word complement is something which completes, makes up a whole, or brings to perfection. Clearly, that definition meshes well with the mathematical definition which we have been studying in this section. An event and its complement together complete or make up an experiment's whole sample space and help to bring to perfection the calculation of the probability of the occurrence of an event.